Okay, so the last thing that I want to talk about in this first chapter here of organic chemistry is to sort of give you a preview of some stuff that we'll see down the road, and maybe a recap of a couple things that we've seen already. And that is to take a look at some common functional groups that we're going to see and that we have seen so far. Right, and first thing we need to say is, what is a functional group? Well, a functional group is a collection of atoms that give certain or characteristic properties to a compound. All right, and we're just going to sort of walk you through a couple things here in terms of these functional groups. All right, so a couple of these we've seen before already. So we'll say name functional group. Structure. And then we'll provide an example. All right, so the first one that we saw was our alkanes, right? And these just have carbon to carbon single bonds. Okay, I'm not going to provide examples of these. I think we've sort of addressed that already. We've looked at our alkenes, which had carbon to carbon double bonds. And then we've also looked at alkynes, which had carbon to carbon triple bonds. And then we also saw our aromatics, which had benzene. As part of the structure. All right, so all of these really didn't have any special collection of atoms. They were just the different types of bonding that we observed. So now we're going to take a look at some of the other functional groups that we're going to see that contain atoms other than carbons and hydrogens. All right, so the first one that we're going to see here are things known as let's see, use the blue one, are things known as aldehydes. All right, and aldehydes are characterized by having a carbon that's double bonded to an O, and then an H on the carbon. So you'll notice here that this carbon has a total of 1, 2, 3 bonds. The fourth bond here, we're going to say it's to R. And whenever you see R in organic chemistry, R just means a carbon containing group, right? It can be a single carbon, it can be 5 carbons, it can be 50 carbons, it can be whatever. It's just something else, in other words, right? But you have to have, to make it an aldehyde, you have to have the C double bond OH to be there. So an example of this would be maybe something that looks like this. All right, that's the simplest aldehyde that you have. Or if you were to draw the the line angle formula, it will look something like that for a longer aldehyde, right? So here we have a carbon over here, we have another carbon there, one carbon here, and another one. So what makes this an aldehyde, again, is the presence of the C double bond OH, which is this part of the molecule. All right, so that's an aldehyde. A relative of an aldehyde is called a ketone. And a ketone is going to look just like an aldehyde, except now that C double bond O is surrounded by 2 carbons. All right, so for instance, we can have a C double bond O, and then we have a CH3 on one side and a CH3 on the other side. Or if you were to use the line angle formula, it looks like this. Or you can have something, whoops, a little bit longer. You can have something that looks like that. Right, that is an, oh, I'm sorry, that's a ketone as well. We can also have something known as a carboxylic acid. Right, and your carboxylic acid is going to look similar to a ketone and an aldehyde. There's a C double bond O, and now on one side there's an OH, and then on the other side there is that R group, either a carbon-containing group, which can be a single carbon or a bunch of carbons. All right, so the simplest carboxylic acid that you have will look like this, right? Or you can have something a little bit longer. All right, so this here makes it the carboxylic acid, that's C double bond O, OH. Relative of a carboxylic acid is something known as an ester. An ester is going to look similar to a carboxylic acid, and that's because it is actually made from a carboxylic acid, right? So we're going to see a C double bond O connected to an R on one side, an R group, and then an OR on the other, right? So it looks similar to a carboxylic acid, but now instead of that H attached to the O, we have another R group. So for instance, we can have something that looks like this. Right, so your carboxylic acid would be, I'm sorry, your ester would be this connection right there. Okay, another one that we'll see that we actually saw as a product of the hydration reactions was an alcohol. An alcohol has a general formula ROH. So that R again can be anything. It can be a single carbon, or it can be maybe 3 carbons. And then as long as you see that OH, that makes it an alcohol. We have another compound that kind of, the name looks similar to an ester, but this is actually called an ether. And an ether is going to have an R group, a carbon-containing group connected to an O, and that's connected to another R group or another carbon on the other side. So for instance, let me redraw that really quick. So I have something that looks like that. Right, so in this case, I have an O between 2 carbons. That makes it an ether, and those carbons on either side can be, 5 carbons long, or it can be just a single carbon. All right, so these are the functional groups that contain oxygen in them. There's another one that we'll see here in a little bit, but I want to also talk about a couple of functional groups that contain nitrogen. All right, and your nitrogens containing functional groups come in 2 varieties. There are things known as amines. Okay, that's how you pronounce that, amines. And your amines are going to contain an R connected to a nitrogen. And that nitrogen can itself be connected to usually a couple other things, and in most cases they are H's, but they can also be other R groups as well. All right, so for instance, you can have something like that. Okay, that is considered an amine, a special type of an amine, but it is an amine nonetheless. Relative of amine, and it looks similar in the name, is called an amide or an amide. And this is going to have a C double bond O connected to an N H2, and then on the other side of that carbon we're going to have an R group as well. All right, so an example here would be something that looks like this. That would be an amide or an amide, or sometimes maybe you will see something like this. Okay, that's an amide or an amide as well. So we're looking here at the C double bond O N, right? That's what makes it the amide or the amide functional group. And those are very, very common in things like proteins. Really common. That's actually what makes proteins proteins. All right, and then the last ones I want to show you are the ones that contain sulfur, and there are two of these. We have things known as thiols, and thiols have an R connected to an SH. Right, so if I have something like this, right, sulfur and H on one end, that's called a thiol. Thiols typically have sort of a repulsive smell associated with them. They're usually added to natural gas to alert you that there's a leak. So when you smell gas, that's really not the gas that you're smelling, like the methane or the ethane. That's actually something that they add to it, usually a thiol that's really repulsive to alert you that, you know, there's a leak of a gas and you need to stop the leak or, you know, get out really quick. And then the last one is called a Thio Ether. Oops. And Thio Ethers are going to have an S between two R groups, a sulfur between two R groups, and again the R groups is just a carbon containing groups. All right, so this is a pretty good list of all of the functional groups that we're going to ever see in our class. In the subsequent chapters, we're going to focus in on maybe, you know, a couple of them at a time, but I just wanted to give you sort of a heads up in terms of where you're going to see these. And I think one of your study modules forces you to go through and to recognize some of these functional groups. The quicker you get used to them, the better it's going to be in the long run. I think your textbook has a, you know, maybe a better organized table, but it should have the same information in it.